Okay guys, first day of our last unit. We are going to do some simple probability today and counting principle, as you can see here. And then we have geometric probability, which is just probability with shapes, contingency tables, and Venn diagrams to follow. So today we're going to work on simple probability. So everything on this vocabulary page, and you won't ever have to be able to match vocabulary. It's just when I use these words during the lesson, you'll understand what they are. The event is what's happening. So like rolling a die or flipping a card. The outcome, if we're dealing with fractions for probability, the outcome is on the top of the fraction, and the sample space is the bottom of the fraction. And that gives you a probability. Okay, probability is always positive. It's always between 0 and 1. Is never negative. So we're going to try some of these simple probabilities. Right now we're only working with theoretical probability. That means what should happen. So the amount of outcomes in event A over total outcomes. So if I said what's the probability of flipping a head on a coin, your outcomes is 1 out of 2 possibilities. If you were to do what's the probability of getting a 6, well, there's 1/6. That's your outcome over a total sample space of 6 sides of a die. That's theoretical probability. That's what should happen. You should have a probability of 1/6 of getting a 6. Dice on a die. So when rolling a 6-sided die, the probability that you will roll, the bottom of these is all going to be 6s. Sample space for a die is 6 sides. 1 side is a 4. 3 sides are odd numbers, 1, 3, and 5. 2 or 5 represents 2 sides. Okay, so let's check to see if I can reduce any of these. This is equal to a half, and this is equal to a third. Spinner, sample space is 1, 2, 3, 4, 5 spaces. So all of these are going to have a 5 on the bottom. Okay, landing on green. 1 of those pieces of the pie are green. 1 is red. 1 is yellow. Not red would be 1, 2, 3, 4 out of 5. Okay, if you were to select one shape at random, what's the probability of selecting a circle? Sample space is all of the shapes. So it looks like this is a 5 by 5. So there's 25 shapes total. And then we have to count how many are circles. 1, 2, 3, 4, 5, 6, 7, 8. So 8 circles out of 25. What shape has the greatest probability of getting selected at random? So which shape shows up the most? To me, it looks like squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It doesn't say what the probability is. I think it would, well, we can say both. We'll say squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 out of 25 is the probability of being selected at random. Okay, so experimental probability means that you've actually run an experiment and you have recorded the results. So in this case, someone flipped heads 1, 2, 3, 4, 5, 6. So for the experimental probability, 6 out of 10, or 3/5, end up being heads, and 1, 2, 3, 4 ended up being tails. It doesn't match the theoretical probability of being half, but as you do more experiments, it will get closer and should get closer and closer to half. Okay, so let's do some probability. After you've picked your socks, you're trying to pick your shoes. You have 4 pairs of tennis shoes, 6 pairs of dress shoes, and 2 pairs of boots. What's your sample space? 4 plus 6 plus 2 is 12. What's the probability you'll end up picking boots? Out of those 12 pairs of shoes, 2 pairs are boots, or 1 out of 6. You wake up in the morning and you put your socks on for school. In a drawer you have 7 pairs of black, 5 pairs of white, 2 pairs of print. Okay. When you reach in, what could you pick? So your sample space. Your sample space is 7 plus 5 plus 2, which is 14 pairs of socks. What's the probability that you pick white socks? Well, out of 14 pairs, 5 pairs are white. What's the probability you grab either a pair of white or a fun print, or means you're going to add those numbers together? So 5 white socks, 2 pairs of fun print is 7 over 14, or a half. Your friend asks you to play a game. You roll a die and it lands on a 2 or a 4, you win. If you land in an odd number, your friend wins. What's the probability of you, I guess friend wins, we'll put money in there. What's the probability of you ending up winning money? So out of 6 is your sample space. You win if it lands on a 2 or a 4. That's 2 out of 6 numbers, which is 1/3. What's the probability that neither of you win any money? Well, the only outcome, so it lands on an odd number, is 1, 3, and 5. You win if it's a 2 or a 4. The way that nobody wins is if you get a 6. So that means you roll a 6. Only one of those possibilities, 1 out of 6. Okay, second part of today is the fundamental counting principle. If there are ways for one activity to occur, A ways for it to occur and B ways for a second activity to occur, then there are A times B ways for both to occur. Okay, choices must be independent. They can't overlap. Okay, that's what that means, can't overlap. And I'll show you what we mean in a second. Okay, so a movie theater sells 3 sizes of popcorn, small, medium, and large, with 3 choices of toppings. How many possible ways a bag of popcorn can be purchased? Write out the setup and then give the answer. 3 sizes times 3 choices of toppings is 9 different ways. Okay, that's the counting principle. You are planning to register for next year's classes. You have 4 math classes, 3 science classes, 3 social studies, 2 English classes to choose from. How many ways can you register for each subject area? You have to pick one of each. 4 times 3 is 12, times 3 is 36, times 2 is 72 different ways to pick one from each. Okay, license plates. Your state issues license plates consisting of letters and numbers. How many possible license plates can be issued with 3 numbers followed by 3 letters? So this can be tricky. Digits, you have to think about, when they say 3 numbers, think about digits. There's 10 digits, 1 through 9, and 0. So there are 10 possibilities for that number, and 10, and 10. And then one of the things you do have to know for this chapter is that there's 26 letters in the alphabet. And then you would multiply 10 times 10 times 10 times 26 times 26 times 26. And you end up with 1757600. So 17,576,000 different license plates possible. Okay. So we've done simple probability and counting principle. You need to do the discussion board post for attendance, and it's a Schoology quiz, not a PDF today for your formative. Have a good day.